Hello and welcome to this webinar today. In this tech talk, we will be covering best practice strategies for maximizing your performance and cost savings with EBS and Snapshots. My name is Upasna and I drive product marketing for EBS. With me, I have today Sudhakar Mungamuri, who is the principal storage solution architect who's helped thousands of customers optimize their EBS deployment so that they get most of their workload deployment on AWS Cloud today. In this tech talk today, we will really help you learn all the best practices that we've learned from our customers over the year so that you can maximize your cost savings and performance. Customers have been running their business critical workloads such as enterprise applications, containers, databases, and even big data analytics file engines on Amazon EBS. And we've uncovered over the past decade that customers sometimes run into common pitfalls and common mistakes, which hampers getting the maximum performance and cost savings that they would typically see. So in this webinar today, we will walk you through how you can right-size your EC2 instances and your EBS volumes so that you get the most performance and cost benefits. Then as customers are getting familiar with EBS and using snapshots as well, we will also help you understand how you can quickly tag your snapshots and tag and monitor your EBS and snapshot usage using tools such as Cost Explorer so that you have constant visibility into what your spend is today and you can optimize based on your business needs. Over the past 1 year, EBS has also done a lot to really simplify and automate how you manage your snapshots. So we'll talk about tools and processes that can help you automate your snapshot lifecycle management, which means greater simplicity and greater cost benefits for you. Then we will dive deep into a CloudWatch demo. This demo will really help you understand what are those key metrics that you can track for EBS volumes and how you can optimize those to meet your unique business needs. And lastly, in the past 6 to 12 months, and even in the past decade, to be honest, EBS has done a lot of innovative launches and that have really helped customers simplify their EBS deployment. So we will walk you through some of those key features and capabilities, which will again help you drive better performance and cost savings. If you're interested in learning about other capabilities that drive operational excellence, feel free to reach out to us and we would cover that in a subsequent webinar, or we have a lot of best practices, white papers, and guides that will help you achieve that. With this, I will pass it over to Sudhakar, who will actually kickstart this presentation and talk about what Amazon EBS really means for our customers, and then walk you through the journey of optimizing your deployment.
Thank you, Upasna. Hello, everyone. My name is Sudhakar Mungamuri. I'm a principal storage solution architect. Let's start with an Amazon EBS overview. What's Amazon EBS? It's an easy-to-use, high-performance block storage service for use with EC2 instances. And EBS snapshots are point-in-time incremental copies of EBS volumes that stores the data in Amazon S3 at the S3 durability and availability. Instant Store provides temporary block-level storage for your EC2 instance. Instant Store is located physically on the EC2 server that the disks are attached to. The data in an Instant Store persists only during the lifetime of its associated instance. If an instance reboots, the data in the Instant Store still persists. However, the data in the Instant Store is lost under any of the following circumstances. Say, for example, the underlying disk drive fails, or the EC2 instance stops, or the EC2 instance terminates. Let's talk about the data services of Amazon EBS. First, Elastic Volumes. Elastic Volumes allow you to increase storage, tune performance up or down, and change volume types without any disruption to your workloads. We also offer Amazon Data Lifecycle Manager, an easy-to-use tool for automating snapshots and snapshot management without any additional overhead or cost. Coming back to the Amazon EBS volume types, GP2 or general purpose volume provides IOPS performance backed by SSDs or solid state drives for most workloads with predictable baseline and burst performance. Provisioned IOPS or IO1 volumes are built for critical and IO intensive workloads needing consistent high performance. ST1 and SC1 volumes are hard disk drive or HDD based, and they are designed for analytics workloads and colder throughput oriented workloads respectively. EBS volumes attach to the EC2 instance, which means, as we discussed before, they persist independently from the life of your instance. If an instance happens to go down, your volume remains. Many volumes can be attached to an EC2 instance. And last year, we launched a new feature called multi-attach for provisioned IOPS IO1 volumes in select regions. With this feature, you can attach up to 16 EC2 instances to a volume. However, this requires that the applications manage IO fencing or concurrent write operations at the application level. What are the workloads that our customers run on EBS-backed EC2 instances? Common enterprise scale relational databases such as SQL Server, Oracle Database, SAP are widely deployed on EBS. In addition to that, open source relational and NoSQL databases such as MySQL, Postgres, Cassandra database, Mongo, etc. are also run on EBS. Building on EBS offers the flexibility to choose any instance and any volume type that meet your workload requirements. In addition to that, EBS is also used for big data workloads and streaming workloads like Kafka and Splunk, Hadoop, and data warehousing applications. File systems built on top of EBS volumes can also serve your media encoding, transcoding, and rendering workloads. EBS has 5 nines availability at an annual failure rate of 0.1 to 0.2%. This is where your snapshots come into play to protect your data for your business continuity and disaster recovery through EBS snapshots. Let's talk about EBS optimization. Optimization comes in 2 different axes, performance optimization and cost optimization. In a way, performance and cost are kind of related. That is, if the resource is undersized, say it is the EBS volume type or the EC2 instance type, you are wasting performance. On the other hand, if the resource is oversized, you are wasting cost. So right sizing your EBS volume type and EC2 instance is the key for your workload optimization. What are EBS optimized EC2 instances? They offer dedicated network bandwidth for Amazon EBS IO data path. Most modern generation EC2 instances, EBS optimization is enabled by default. They deliver dedicated bandwidth to Amazon EBS. When attached to an EBS optimized instance, GP2 or general purpose volume are designed to deliver their baseline and burst performance 99% of the time, whereas IO1 or provisioned IOPS SSD volumes are designed to deliver their provision performance 99.9% of the time. Last year, we introduced a 36% increase for select Nitro instances for EBS bandwidth from 14 gigabits per second to 19 gigabits per second. Let's talk about right sizing your EC2 instance for better performance of your workload. Take the example of an application that requires 2 terabyte of a GP2 volume at a provisioned IOPS of 6,000 by the sizing of the GP2 volume. Choosing the right instance type is key here. So if you select a C4 large, for example, that specific instance has a baseline of 4,000 IOPS, whereas your application workload expects 6,000 IOPS during the peak. However, if you attach a C4 4x large instance, EBS optimized bandwidth is about 16,000 IOPS. So this meets your application requirements of 6,000 IOPS. So the summary here is EC2 instances have performance thresholds. EBS volumes have their performance thresholds. The lesser of these will dictate your EBS maximum performance. Let's talk about the elastic volume feature of EBS volumes. Sometimes, most of the workloads, it's difficult to know ahead of the time what the exact needs of your particular workflow might be. So Amazon EBS removes a lot of this guesswork around storage planning. This is where elastic volume feature comes very handy. When using EBS, it is always best to start with the minimum amount of capacity to reach the needed performance. EBS should be provisioned to a minimum size because upsizing is easy with zero downtime, whereas downsizing a volume from higher capacity to lower capacity requires administrative intervention and high effort. You can change volume types using EBS Elastic Volume feature. There is no cost to modify volumes, and the changes are made dynamically with no downtime required. The new configuration is in effect at this point when you issue a modification. However, the optimization may continue for many hours in the background. Billing for the new configuration begins as soon as the state turns to optimizing. How can you monitor the status of your elastic volume modifications? You can use CloudWatch events to send you alarms and alerts based on the success of the status check of a modification to an EBS volume. Please note, if you reach the maximum volume modification rates for your volume limit, you will need to wait at least 6 hours before applying further modifications to the same volume. Let's talk about monitoring the EBS volume performance. CloudWatch publishes, Amazon EBS publishes volume metrics data to CloudWatch. CloudWatch metrics are statistical data that you can use to view, analyze, and set alarms on the operational behavior of EBS volumes. As shown here, GP2, ST1, and SC1 volumes publish metrics to CloudWatch at a granularity of 5 minutes, whereas provisioned IOPS IO1 volumes send 1-minute resolution metrics to CloudWatch. Let's do a demo and see how you can monitor total IOPS for an EBS volume using CloudWatch metrics. In this demo, we will apply Amazon CloudWatch metric math to EBS volume performance metrics for total IO operations per second, or IOPS. Total IOPS is a derived metric, also known as a rate metric, from basic volume metrics, volume read operations, and volume write operations, or volume read ops and volume write ops, respectively. We will also create a dashboard in CloudWatch console. Let's walk through the process step by step by logging into the browser window for Amazon CloudWatch console. Navigate to the desired region, for example, here showing as Northern California, and select Metrics and EBS Metrics, and click through Per Volume Metrics. In the Per Volume Metrics tab, you will see a list of all EBS volume resources for that region. Select the desired EBS volumes. For example, here I have selected 2 volumes and their respective read operations and write operations. In the Graph Metric tab, you will see the list of all volumes that you have selected, and you create a math expression. Say, for example, V1 for volume 1 and V2 for volume 2. which is the sum of read and write operations divided by the period for that specific interval or resolution. Here, which is 1 minute for IO1 or provisioned IOPS volumes. Similarly, create another math expression for volume 2 we have chosen with its own read operations and write operations divided by its resolution granularity of 1 minute. And in the graph options and source tabs, let's examine those closely. In the source tab, it will display you the policy document for each of these volumes that you have created. This way you can leverage, copy the source and edit it and use it to update, to add more volumes as you need instead of going through the CloudWatch console clicks. So here I have added 2 more volumes, volume V3 and V4 with respective volume IDs and their respective read operations and write operations, and created metric math for the total IOPS. Once you apply this, you will see the graph metrics tab view of all the selected volumes, V1 to V4, for total read-write IO operations per second. And then you can add it to the CloudWatch console dashboard. So here in the CloudWatch console dashboard view, you have named your the new dashboard you have created called Production EBS Read-Write Operations, and added these 4 volumes. You can expand this view by clicking on the volume and adjust your view time period. In addition to that, you can also select individual volume that you would like to dig deeper into and apply, so that rest of the volumes are grayed out and you can examine a specific volume of your choice. In addition to that, you can also create actions. For example, you want to create an alarm to alert when the IOPS reaches a threshold or it is lower than a specific threshold that you already set. CloudWatch console takes the raw data from CloudWatch API and displays a series of graphs based on the data and metric math. Depending on your needs, you might also want to consider to get the data directly from the Get Metrics Data API and consume in your monitoring tools. Moving on to the EBS Snapshots and Data Lifecycle Manager. EBS Snapshots, as we discussed earlier, are point-in-time incremental copies of an EBS volume that are crash consistent and stored in Amazon S3. What is incrementality here? Let's talk about that. Say your application is modifying a few blocks of a data file. EBS service tracks those changed blocks, and only those changed blocks are saved into S3. However, EBS Snapshot contains all information necessary to restore a volume to point in time to meet your business requirements. For volumes that have been created from EBS Snapshots, in order to achieve full performance, you may already know that we recommend initializing, that is, reading every block using commands like FIO or DD for Linux environments to get full performance. Last year, we introduced Fast Snapshot Restore, FSR. So our customers are using EBS Snapshots in new and interesting ways. Say, for example, they're using data drawn from production to test environments and analytical environments, or support virtual desktop interface VDI environments, where they have to create multiple volumes, restore multiple volumes out of a given snapshot. So customers with these new use cases asked us how they could very quickly create many volumes from these snapshots they have taken and have those volumes to be ready to deliver maximum performance right away without any initialization. So FSR enables you to do this exact thing. You can enable it for a new and existing snapshot on a per availability zone basis, and then create new EBS volumes that deliver their maximum performance. This performance enhancement will allow you to build AWS-based systems that are even faster and more responsive than before. FSR can be enabled on Snapshot even while the snapshot is being created. So for example, if you create nightly backup snapshots, ahead of the time you know that you have a predictable restoring schedule, enabling them for FSR will allow you to do faster restores the following day, regardless of the size of the volume or the snapshot. When FSR is enabled for a snapshot in a particular availability zone, a bucket-based credit system governs the acceleration process. You can use the per minute CloudWatch metrics to track the state of the credit bucket for each FSR enabled snapshot. You can take crash consistent snapshots for multiple volumes attached to an EC2 instance. These volumes may be part of a RAID group, and you can also exclude or include boot volume as per your requirements. How do you choose multiple volumes to create crash consistent snapshots at any specific time? So you have to specify an instance to take the multi-volume crash consistent snapshot. For Windows environments on Amazon EC2, you can take application consistent snapshot of all EBS volumes by using AWS Systems Manager run command. This in turn uses the Windows Volume Shadow Copy Service, also known as VSS. We have many customers that use snapshots to restore and also enable FSR for a lot of snapshots to meet their business requirements. So the manageability of these snapshots, we have launched many new features to Amazon Data Lifecycle Manager. Data Lifecycle Manager, or DLM for short, uses policies to define backup schedules. You specify when you want a snapshot to be taken and how often, and the DLM service will take care of creating the snapshots for you. This is a great feature for our customers that need to automate the snapshot management and hold it for a certain period of time and auto expire by age or by the count of snapshots. When you define a DLM policy, you specify volume tags to identify which EBS volume should be backed up. You can also use IAM policies to fully control access to DLM policies. There are two new features that we released last year: cross-region copy of snapshots to meet your DR and business requirements. In addition to that, you can set your remote region retention policies independent of your source region snapshot policies. Most of the time, customers ask me, what happens when we delete a snapshot? So let's talk about it here. When you delete a snapshot, only the data referenced exclusively by that snapshot is removed. Unique data will not be deleted unless all the snapshots that reference that data are deleted. Deleting a snapshot of a volume has no effect on the volume. Deleting a volume has no effect on the snapshots already created from it. If you make periodic snapshots of a volume, we discussed earlier, the snapshots are incremental. This means only the blocks on the device that have changed after your previous snapshot are saved in the new snapshot. So some customer asks, so if the snapshots are incremental copies, what happens when we delete a previous snapshot? Even though the snapshots are saved incrementally, the snapshot deletion process is designed such that you need to retain only the most recent snapshot to restore the volume to that recovery point in time. Data that was present on a volume held in an earlier snapshot or a series of snapshots, we also call it lineage, that is subsequently deleted from the volume at a later time, is still considered unique data of the earlier snapshots. This unique data is not deleted from the sequence of snapshots unless all snapshots that reference the unique data are deleted. So we talked about EBS volumes and EBS snapshots. So in the next few minutes, let's spend some time on tracking EBS snapshots usage and spend through AWS Cost Explorer. AWS Cost Explorer has an easy-to-use interface that lets you visualize, understand, and manage your AWS costs and usage over time. Cost Explorer provides you with a set of default reports that you can use as the starting place for your analysis. And from there, you can use the filtering and grouping capabilities to dive deep into your cost and usage data and generate custom insights on the EBS usage and spend. Cost allocation tags are very important for you to create this view of EBS volume and snapshots for a specific business function or an environment, or for that matter, a specific set of EBS volumes to track both EBS usage and snapshot usage and spend respectively. EBS now supports cost allocation tags for both volumes and snapshots within the AWS billing and cost management dashboard. You have to activate user-defined tags for cost allocation. The user-defined tags are nothing but a key value pair. Key could be a name or a function or a purpose, and the value, its respective value that you define. For example, key could be environment, and the value could be production or QA or staging. Using cost allocation tag, you can now classify snapshot costs to match the needs of your business for better transparency and visibility. You can also use this feature to allocate snapshot costs to internal teams, for example, to provide accurate reports for customer billing. Let me repeat, to get started, you have to tag your EBS snapshots and go to the AWS billing and cost management dashboard to activate cost allocation tags for reporting, or use tags to filter views in the Cost Explorer. If you're using DLM for your snapshot management, you can inherit the snapshot tags from your EBS volume tags, such that you get a holistic view of your EBS volumes and their associated snapshots at any given time. Let's take an example. In this example, we use Cost Explorer to filter usage type, say for example, EBS snapshot usage and EBS volume usage. Select the time period of your choice, month or annual, and the resolution daily or monthly. And then group it and filter it by the tag option on the right-hand pane, and view it by tag or usage type for your EBS volume and its associated snapshot usage and cost. A cost allocation tag is such a powerful tool that will help you here understand your usage and cost broken down by a name tag in this example, for example, EBS volume and its associated snapshots over a period of time. You may ask, so what is the granularity of this data that I can extract from Cost Explorer and cost allocation tag combination? So this gives you a flexibility for you to be as granular as possible, to go to a specific EBS volume and its snapshots, or aggregate holistic to a department level or a function level or an environment level for your business requirements. Some of you would like to have this extracted programmatically. So Cost Explorer provides get, cost, and usage APIs. You can extract the same data using those APIs. In addition to that, cost and usage reports or CUR reports are also available for you to generate the same data and dump it into a database and run insights on top of that. Please note that this method is only as accurate as that of the cost allocation tag and naming and activation regimen in your environment. In summary, let's wrap up what we have learned so far. The use of right choice of EBS volume type is critical to meet your application workload based on the throughput and IOPS requirement. EC2 instance right sizing is very critical to prevent performance bottlenecks. Tag everything. Snapshots inherits from EBS volume types to establish cost visibility. Understand where the low-hanging fruit is in your case for optimization. This could be identifying unused volumes or unattached volumes. You can run those reports through Trusted Advisor or through EBS console or through CLI and command or APIs. Then take a snapshot of those unattached volumes and you can delete those volumes. Investigate why the volumes are unattached in the first place. Leverage tools for finding these resources and optimize cost. Some of the tools we already demonstrated. Trusted Advisor is another tool that will help you understand these unused resources. Increase elasticity. Leverage EBS Elastic Volume feature to start small and grow programmatically through automation, depending on your size and IOPS requirements. So this will help you to avoid waste. What do we need from you? To learn more, go to the links shown here at Amazon EBS page. There is a lot of information about EBS volume types, their respective performance characteristics, and the latest throughput characteristics as well. EBS optimized EC2 instances are provided here in this reference. This will help you select the right fit for your workloads in combination with the EBS volume types. Start creating EBS snapshots. Either you followed DLM or AWS SDKs or EC2 console or AWS backup. The snapshot behavior is the same. They're all incremental copies saved into the S3 with S3 durability. You can further lifecycle manage the snapshots using Data Lifecycle Manager, DLM, and then expire aged snapshots, which based on your business requirements, and then learn how you can benchmark some of these EBS volumes for your specific workloads. The reference provided here will give you some of the tools that we have documented on these pages. Thank you, and let's take some questions now.